But at the end of the day, all of these operations, everything that needs to be added, they actually bring a really common problem called growing code base problem. It's actually a common term. How many of you have heard of it? The problem is, as your project grows, I was talking to a friend of mine, he is working on WhatsApp, and I was telling him, yeah, it's just a chat application. Meanwhile, it's a like billion-dollar industry, right? And the billion-dollar industry out there is there because nothing is as easy or as simple as it seems. So that brings us to this problem. Nothing is simple. Nothing is just an app. Everything that it grows, every decision that it brings, the fact that you need to think deeper things. And as you think through the deeper decisions, deeper features, deeper use cases, different devices, different platforms, then you will see that your code base will grow accordingly. Every single data that has been processed is mixed. So it will escalate the problem, a challenge of what are you going to be doing for fixing this problem. All right, so everyone with green lights on the headphones, can you hear me? All good? Perfect. Okay, first of all, thank you very much and welcome to the Droidcon Italy's first day. I am in the best position today, like right before the lunch. So I will go through everything. I hope that I will first feed you with information, then you can carry on with the lunch afterwards. I've seen the lunch a bit. They look amazing, no surprising. So I'm Sali, I'm based in Berlin, and right now I work at AWS, and what I do is I try to teach people about how they can use cloud to build their mobile applications. But today, I'm not going to be here as a cloud developer advocate. I'm here to talk to you about how you can build Flutter applications. They answer the questions of what, when, and how. With my interest or with my experience with Flutter, I have started to build Flutter applications in early 2017, when it was alpha, when .1.0 was there. We were using the new keyword. It was quite annoying back then, but being an early adopter really helped me out to actually pave my way into the community and get better with this technology. So today I will share some insights and I will answer some frequently asked questions about this topic, and last but not least, I will get your questions. So first, everything that I will be saying is my opinion, so do not see this as a guide or anything. I'm just sharing my experience through what I heard and through what I have seen in my career so far. As I said, we will answer first what is the common architecture patterns, especially recently Flutter has announced a new architecture guide. We will discuss that as well. We might be answering why do we need it. It will be a brief, and we will see how you can implement it with an example, a basic example that I have created as well. So once you have an app idea, you know that you have some questions that needs to be answered. You need to define your needs and everything. Once you have the rough idea about application, then you answer the question of how am I going to be building my application from the architecture perspective? What pattern I will be using? Even how you are going to be building your file structure is a question. Besides that, of course, the state management. State management is a big topic. Some people love Provider, some people love Report. I personally really love Block. And anything that you would love, it's actually on your own good, but you need to pick the right tool for your right job. The routing, Go router has been one of the discussion topics, at least for me. It's a nice library, but sometimes it can be too opinionated to break my flow. But for example, I want to ask you a question. How many of you have used the library AutoRouter? How many of you have used RouteMaster? See, the Go router actually killed really great libraries like RouteMaster that has made a bigger impact in the community back in the days. But right now we have the Go router. It is the hero that we need, so we are using it right now. And of course the data management and everything. Why am I telling you this trivial looking things? They are not actually trivial. They will impact every decision that you will have along the way. What do I mean? From the file structure perspective, we can have the feature first approach that someone likes. We can have the folder first approach that the others likes. For example, how many of you likes the feature first more than the other? See, and for the other one, the rest is, I guess, So the thing is, every decision is really personal. That's why the questions needs to be asked, and that's why everything that you've seen so far is trivial to each of you, but the answers are highly complicated because they are on the personal level. And of course, you have other things, the architectural patterns like MVVM or like domain-driven design or like MVC, the clean architecture, and like everything at all. We'll go back to the architecture patterns in a second, but we also have highly opinionated ways of doing things as well. For example, there's a library called rearch for an architecture template. How many of you have heard of that? It's actually a really useful library in case you're new to the Flutter. You can build everything on top of that, which I think something Flutter was missing from the day zero, because I come from the Android world as well, and Android had a lot of libraries that could help you out to build the common architecture patterns like MVC and so on. Also, there are a lot of architecture templates, there are architecture samples, like you can just see how others are building, get it, clone the project, and carry on as well. So let's take a step forward, and what do we talk about architecture patterns? The architecture patterns is a big topic. I know that. How many of you are using social media? Like in the social media right now, like there's a crazy amount of discussion about what is MVVM, why is this the worst for Android Flutter? No, it is the best for Flutter, and the MVC and like domain-driven design is the best because I like the Reso coder the best, and so on. Like everyone has their own opinions, but to be honest, I think this also comes from the fact that Flutter is like really, comparing to technologies, I'm not saying it's new because like I've seen it in early days, I've seen it in stable, and I know that like right now it is like highly compatible through your needs. But at the end of the day, you might think that every opinion is loud because like the people who speaks out is like only a few amount of people. Anyway, so we have all these architecture patterns. Like how many of you have been stung by the clean architecture, for example? Yeah, it is quite like it is the most misunderstood concept out there that could help you out. So why am I telling you these stories? Why is it like going back? Think about this. This is what Flutter has offered recently in the documentation website. They said this is the architectural approach that we suggest people to have. Like this is the UI layer. Everything UI related will be in this layer. View will be dumb. It will just do whatever needs to be done. The view model will handle the business view logic. So in case you want to increase a value by 1 and return, that function needs to happen in view model because, as is understand from the name, they said let's use MVVM. And behind the scenes, all these interactions will happen for your data through the view models. So meaning that all these important decisions or all these important operations will happen in another place. The idea of this was to make it testable, to make it more easier to use. And in the simplest way, when you think about it, it actually goes back to this. You have view model, you have your view model to talk to your data layer. It can be repositories, local repositories or remote repositories, and they can talk to the service to bring the data. The view model itself is, again, whatever you can do. People can use the state management, for example, to make it work through your actions and everything. And let me be sure I'm okay with time as well. In addition to this, we have the repositories. Repositories needs to be like pure Dart, of course. They need to just talk to the related place. Do you want to have your local storage? Then you need to call your local storage through your repositories, or you want to call your services, you can call it from there as well. This layered architecture structure that has been offered to you is actually giving you a chance to have a proper way of having separation of concerns. But at the end of the day, all of these operations, everything that needs to be added, they actually bring a really common problem called growing codebase problem. It's actually a common term. How many of you have heard of it? So the growing codebase problem is actually, like all of these that you've seen so far, you might say, yeah, that looks nice. Like it has the unidirectional data flow. You can see that the view has been split up by the business logic. So everything looks nice. You do everything in its own place. But what's the problem? The problem is, as your project grows, I was talking to a friend of mine, he's working at WhatsApp, and I was telling him, yeah, it's just a chat application. Meanwhile, it's a like $1 billion industry, right? And the $1 billion industry out there is there because nothing is as easy or as simple as it seems. Everything, whoa, there was a sound here. I thought I was going deaf for a moment, but the sound was gone. Anyway, so that brings us to this problem. Nothing is simple. Nothing is just an app. Everything that it grows, every decision that it brings the fact that you need to think deeper things. And as you think through the deeper decisions, deeper features, deeper use cases, different devices, different platforms, then you will see that your code base will grow accordingly, and all of a sudden everyone's responsibility is mixed, what they are working on is mixed, every single data that has been processed is mixed. So it will escalate the problem, a challenge of what are you going to be doing for fixing this problem. And how many of you are coming from the Android world? Nice. So like for the one thing that I really liked about Android was this, like their documentation. And for the modular architecture, it was a common use case for a long time for Android apps because it had many benefits, many positive sides that it was bringing. Flutter also brings some, but we will discuss it in a second. What they had was this like great approach that shows you how you can modularize your applications. And the most important part is like you define your features, you define your libraries, or you define your packages that can help you out to do certain operations that can work as plug and play, so you don't need to worry about breaking the other side of the code while you take it out or pull it in. I really like this one because it shows a lot of complex scenarios and sharing multiple packages together as well. So, modular architecture. Modular architecture actually is encapsulating each feature and each operation into its own environment, so you can plug it into an app or bring everything together like they are Lego pieces and pull out a new application that could work in a unique way. This is really valuable because it gives you a chance to have independent development environments while you're working with the teams. Let's think about this like super simple diagram, okay? And we have the mobile app on top of everything. This is what users see. But what we have is we have, for example, core module. It shares resources on the level of it shares the common databases and so on. It does, for example, network preparation to provide these information to the modules or use it by itself. The feature model one here just shows like the resources that it has, and as you see, it can have its own UI, API models. And when you think about it, each feature model that we see here is actually working as its own application and its own component. So as you have more components running in parallel, you will have more freedom for each fork. For example, the person A can maintain and work on core modules, the person B can work on the feature module 1, 2, etc., going this way. So let's see what I will be showing you as a sample app. So I will just go back to this. I think I will increase the font size in all editors. I totally forgot. Let's make this bigger. Okay, we will go through multiple things together. One of them is the sample app. It's a super basic application that I created so we can understand the concepts together. And for the deeper side, we will go into details together anyway. Okay, the first part is it's the Flutter application. We have the main function that gets the modular app. The modular app calls a feature A page. We will be seeing a list of items that we have. And in the feature A page, if we go, we will have a list of libraries that we get, and from the libraries, we will get the information, and when everything is done, we will show it on the screen. And once everything is done, we will have a clickable button. We will see the demo in a second. I think I can explain it better on the demo. Let me run it. And in the feature B, we will be doing different thing. So what does it bring to the table? We will see each item or each library plus the UI component is actually independent from the business logic perspective. So we'll wait a second. I built this really quickly, so we don't have the loading indicator right now. It is loading the data, so it will take a few seconds. So yeah, so we have like this information. This is not a special information. This is what I get from a JSON placeholder website that is online and it's free and that anyone can use. So we go to the details. It's posts, and each post has a comment, and for each comment per user you can see the user information as well. And each feature will have a specific role and reason to bring to the table. So I go back, and it is working fine. So let's go through our models. Let's go from the top to the detail, then we will slowly wrap up to the questions part that I will be answering first, and I will get your questions. The first part is here. From my applications perspective, I will get two packages. These packages are called Feature A and Feature B. Feature A is the first site that we have seen, and Feature B is the detail site that we have seen. And we call this as a normal library, so nothing too fancy about this one. The Feature A here is actually, it has like calling a service perspective, like generating the values, bringing together and returning them as a post object that is part of the Feature A. And if you go to the details of it in the pubspec.yaml file, we can see that the data A and data B, like one more layer of the complexity is there. What do I mean by this? If I need the data A in one package and not needed in data B, I don't need to have that complication working for me. What I can do is I can just bring it back. And the data A is the user operation part, like fetching the users and like fetching user by ID. And when you look at it, it only has a reference to the HTTP library, so it doesn't do anything extra. So when we take a step back, we have the app, we have the Feature A and Feature B, and Feature A is using data A, data B, and the Feature B is using data B and data C. But when they're using the same library, how can they are working together? They are working together because of multiple reasons. One of them is they don't have any conflict in interest. And the second thing is when you use the packages, there's still the tree shaking capabilities working behind the scenes to get rid of the parts that we don't use at all. So once you have your production environment ready and moving forward, the conflicts will not happen if and only if your library versions are okay and if your application is built, which is something that we will discuss in a second as well. And how it is actually living in the same code base or in the different code base, or how you can manage it. Flutter has tools. Flutter has tools that is coming from the open source world that you can use to manage and build on top of things. What do I mean? The biggest one is called Melos. Many of you have heard Melos? Nice. Melos is actually a tool that is working for monorepo approaches. So when you have a monorepo structure, it helps you to manage each package or each repository, sub-repository, through the central approach. So for example, in case you want to run the tests, you can run the tests. In case you want to work with, check out if every setup is fine and you can build it, you can still build it. And how we do it is we create a Melos.yaml file, we define the packages that we want to manage, and for each package you just run some scripts. You just create some scripts. Like you can run the test for everything. You can also run the test for each item or each package as well. And one thing that you can do is you can also write custom scripts to generate files for each thing that each package that exists. So if I open up my terminal and say Melos run test all, it's going to run the tests that I have for each package, and it's going to show a successful fail structure. And you can see that I have actual tests for each service that has been created to see if they're returning the value that I need and if they are working as I expect it to be. So let's talk about the advantages and what it brings to the table. Then we will go back to where we are. So right now, imagine that you don't have 5 things. Like there are big packages right now. Like I've seen talks from folks from the major big companies, and they have like hundreds of models that each team is generating. And if you work with some structure called cross-functional team, you will see that teams will be managing only feature because they are so big and complicated. It will take time for them to bring in a single change into a big feature approach that we have. So that is why it is important to have this flexibility of creating a freedom for each individual or each team that can have a way to integrate or move forward faster. I'm looking at the time for you so we don't miss the lunch. 10 minutes and we will be good. I know you're hungry because I know I'm hungry, so we will get to food. Okay, so we have seen that we have the libraries and what happens between the multiple dependencies into the libraries. You can see it in the feature A perspective as well. Because in the feature A perspective, the Melos will, the feature A perspective, anything that it uses, it's actually a library that you would normally use. It can be HTTP or whatever it is. And behind the scenes, you will not be calling nothing but a class out of a library that you would be normally doing. So from your perspective, actually, you just create libraries, put it together. So you have Lego pieces, bring it together, and bring a bigger piece to make it out of a, I don't know, like fish or something. So that is why each approach is going to work as we expect it to be. So what we have here, we have the feature A page. The feature A page is, when I go to the detail, I see the feature B page. Let's see how it is doing all the calls and everything. So I go to the feature A page. In the feature A page, first I load the library because I will be calling a library out. I will be calling this library to get the feature A perspective. And in the feature A, what I have is feature A post with usernames function that comes from the feature A.dart library. So I went in one level down. And in here, it calls the service from the data A and brings back whatever information and it returns me. So I see the posts with the usernames here. If I go to the feature B, let me go to the feature B. I have a reference to the post ID. What I want is I actually want to get the comments of the post. And if I go to the feature B, it's a different library. It still gets the comment per post from the data A, but also, get the post from data A, but gets the comments from data C. So that even though they look like they are working together, they are technically separated, doing separate things, having separate responsibilities along the way as well. So it creates what it needs to create and returns per post title as well. So you can see that in this page, we are calling one library. In here, we call another library, but technically, they're part of the same app. You might be saying, yeah, but this is normal. But yes, this is normal, but this is actually a granted architectural approach that you would be using for your applications. So even though this might look simple, imagine it with hundreds of packages with, for example, a retailer app that you're working on in different countries, and they have different regulations, and each regulation is a different module. So you bring in whatever you need per your application and per your build as well. So going back to the slides. So the pros of this is reusability. So you can reuse the packages like you've seen it feature A and feature B. The ownership is you can split the ownership between the teams and people. So you can define who is working on who. You can have this nice separation between the teams. They are testable. You have seen that all of these are testable. They have their own tests. So you can define people to write tests for simple libraries as well. And they are encapsulated into their own responsibilities, and you can defer the components. You can load the libraries when you need them, so that's why we had the load library part, that you don't need to directly load it the moment that your app is built, but actually you can use it when it is loaded. The code is, if you're not careful, the code can, the model can get too complex, so everyone needs to know their duty really well. You shouldn't have two big modules. You should have the proper separation. And having two small modules, like saying just hello world, of course, it's a big problem. The possible duplicated code is a big problem in case you don't have a good team sync, good team discussions. You will have hard time to keep track of what is has been implemented or not. The library version conflicts is a big problem, might happen as well, and the navigation is too. So we will also answer how we can fix this as well. First, the frequently asked questions. What are the first steps to transition an existing Flutter project to a modular architecture? So first of all, you need to define your feature and logical boundaries of your application. Then you will define separate modules for each and slowly transition them into where they belong. And you will gradually refactor your code base. First get one module in, use that module, and move forward with it. The next question is, how do you manage dependencies between different modules to ensure they remain decoupled and maintainable? You can use dependency injection frameworks between, so they are controlled by a single source of truth, or you can use like service locators, for example, to create a singleton instance and carry it around your application as well. Or, as I said, the dependency injection is your friend. How do you handle the possible version conflicts between the libraries used in models? This has been a problem in Android as well. You need to decide on the version and lock it. You don't need to use the caret. You know, like you don't need to have the minor updates, especially I've seen many people don't understand what is semantic versioning. They do minor update and everything changes in the API level. So you can define and fix the version and do regular updates as well. This is also important so you don't stay behind. How do you handle routing, navigation in a modular Flutter application, especially when different modules have their own navigation requirements? Libraries like AutoRoute really helps you with that. They have their own system to directly work with multiple packages, but also you can build your own navigation system as well. And what are the most common use cases for using modular architectures? I think the one that I've been telling you is like a team where different teams handle different features where the responsibilities are too complicated for each is the best part. There are core parts, but there are also common parts that needs help with as well. And the last and most important question, should I use it with my project? And this will bring my favorite slide here. It depends. I don't know any of you, I don't know your structure, I don't know what you have, but what I know is in the correct, I really love the term of using the right tool for the right job. You cannot put in a nail to the wall by using a screwdriver. So you need to define, as an engineer, as a developer, you need to define what you need. If you think that you need it, it will solve a lot of problems. That is what I know. But if you don't need it, it will make you hate yourself and your project. So make your decisions wisely. That being said, thank you very much. If you have any questions, you can find me on LinkedIn, Blue Sky, and YouTube. And if you have any further questions, I think we will have time. If you don't have a question and want to run to the lunch, I understand as well. So thank you very much.